So hi everyone, and today we are going to solve this LeetCode daily challenge called maximum matrix sum. In this we are given a square matrix and we can apply an operation in which we can pick two adjacent elements of matrix and multiply each of them by -1. And after applying that operation we need to calculate the sum of the whole matrix. And what we need is to maximize this sum. So if you do some dry runs using these test cases or some your generated test cases, you can make some observations. So the first observation which I made was, if the number of negatives is even, then after applying some operations, all of these negatives can be converted to positives. So all of them can be converted to positives. With this we can say that the sum of absolute values of the matrix will be maximum sum. Second, if the number of negatives is odd, then we can convert all the even number of negatives into positives, and we will have only one negative remaining in the matrix. So only one negative will remain. And by doing some operations on this one negative, we need to move this negative sign to the minimum element of the matrix so that the sum is maximized. Move this negative to minimum element of matrix to maximize sum. If the matrix has 0, then using that 0 we can create negatives in the matrix, because for 0 the sign won't change, but the other number associated with that, its sign can be changed. So if we have even number of negatives, then we don't need to use this because we already have the maximum sum. But if we have odd number of negatives, we can generate a new negative and make the total number of negatives even, or we can change one of the negatives to positive and then convert the remaining negatives into positive. So if the matrix has 0, then all of them can be converted to positives. So keeping these things in mind, we can start writing a solution. So n will store the matrix length. Apart from that, total sum will be long, and there is also count variable which will count the number of negatives in the matrix. And apart from that, what we can do is we can have minimum negative. This min negative will store the this for second condition. We will have only one negative and we need to move this negative to the minimum element of the matrix, so that minimum number will be stored by min neg. Okay, so you can what you can do is, if the number is negative, then we need to pick up the maximum number possible basically. So integer of min value, something like that. Now if I run the loop on this problem, so here are some things, like for total sum, this will be equal to absolute value of matrix ij. Apart from that, if the matrix of ij is less than 0, then we will count it and we can also have min neg stored here. So min neg will be to mat.max, comma. This we can do here. Or you don't need to do this, sorry. Uh, you don't need to do min neg calculation here because we need to find the minimum element in the whole matrix. Okay, and we will move the negative sign to that element. So yeah, this should be max value, and you can here you can do it like min neg is equal to mat dot min neg comma dot helps matrix. Okay, yeah, now this will work. And if matrix has 0 present, then we can say has 0 is equal to 2. You can also use a boolean as equal to 2. Now we have everything we need. After doing all of this, if the number of negatives is even, then we can just return total sum, because we can convert all the negatives to positives. If this is not the case, if the matrix has 0, or we don't need, we can add it here only, or matrix has 0. If both of these cases are false, then probably the matrix will have no zeros and it will have odd number of negatives. So what we can do is, from the total sum we can remove this min neg and make it negative. We can remove this positive value of min neg from the sum, and in place of that we could add the negative value. So we will remove this positive value from the sum and we will add the negative value of min neg, basically like this. This will give you the answer. So this whole of this will resolve to something like this. Yeah, time complexity of this solution is O of n square, as you can see. So yeah, thank you for watching this video. I hope you enjoyed it. Please share and subscribe. Yeah, thanks.